Let's learn some probability. Boom. These are our objectives. You don't need to write this down. We'll just look at, these are the things we're going to learn. Ready? Alright, so a probability experiment in action or trial. We're going to count specific results. So, for instance, rolling a die, I would like to get a 3. So you roll a die and you want to get a 3, right? The experiment is roll a die, try to get a 3, right? The outcome that we're looking for is getting a 3. Quite straightforward in this case. So, sample space. The set of all possible outcomes in a probability experiment. In the case of rolling the die, what are all of our possible examples? Yeah, so our possible examples are 1, 2, 3, 4. Sorry, possible outcomes, I should say. 1, 2, 3, 4, 5, 6, right? That's our sample space. An event in our sample space would be so a subset that has one or more outcomes. So if I wanted to roll an even number, that would be an event because there are multiple even numbers in our sample space. Okay, so what I was talking about before, rolling a die. So one outcome would be rolling a 3, right? The sample space, as we said, 1, 2, 3, 4, 5, 6. All those are possible outcomes. An event would be, say the die is even, right? Because there are more than one, there's more than one outcome in that event. So there you go. Yeah, so there are examples of each of those definitions. Okay, hey, so let's describe the sample space. If we were to toss a coin and then roll a 6-sided die, so our sample space, right? Each, that's right, each one gets that, that's right. So it's going to look like, let's see what this solution says. Actually, it looks much nicer on this one. I like to use a tree diagram for that. Yeah. So if you have, if you flip the coin and it came up heads, then you have all of these possibilities, right? Heads 1, 2, 3, 4, 5, 6. Tails 1, 2, 3, 4, 5, 6. Which gives you a total of 12 outcomes.
Wow.
So if I was actually going to draw this without a picture of a penny, I put, okay, if it came up heads, I would have 1, 2, 3, 4, 5, 6. And then also if I came up tails, I would have the options 1, 2, 3, 4, 5, 6. And that would tell me my total possible outcomes is 12, right? So my sample space has 12 possible outcomes. And so without having a beautiful picture of a penny, that's how I would write it. So this is an example of a tree diagram that we would use in order to count the number of results in our sample space.
Was it wrong?
All right. Let's identify the sample space of this particular experiment. We're going to determine the number of outcomes and identify the sample space.
No way.
So, we do an experiment consisting of recording a response to the survey
The voice.
and the gender of the respondent. Assuming that they would answer only male or female. Let's see. So you have a choice, right? They answer male, and then you say, hey, you give them the survey. Survey, you can either answer yes, you can answer no, or you could answer not sure. If you identify as female, then you could answer yes, you can answer no, or you could answer I'm not sure. No. Does your favorite team's win or loss affect your mood? It's either yes, no, or not sure, not gender.
No, I thought you said gender. I'm like,
We're assuming you get two choices for gender in this case.
male or female.
What do you do in gender studies? I know it's a college course, but what?
I do not know. I never took a class like that at all.
It's like a serious thing.
The fortunate thing about teaching that is I don't really have to have deep conversations about things like that. So, all right. So here we go. We're going to record a response to this survey, that same survey, right? When your team loses, does it affect your mood? Yes, no, or not sure. But now we're going to say, hey, will you please identify with the geographic location? So they say, okay, identify with the geographic location northeast.
Northeast.
This is what I identify with because I'm from the northeast. And they say yes, they say no, or they're just not sure. And then if they identify with the south, then they can say yes, no,
Yes, my name.
or they're just not sure. Okay, then if you identified with the Midwest, you know, then you might say yes, no, or you're just not sure. And then in the West, where everybody talks normal. Yes, no, we're not sure. And then we can count that out, and we can figure out, so this is what our sample space looks like. How many items are in our sample space? 1, 2, 3, 4 times 3, or 12. Hopefully, locally. So all of this stuff, right? This is our sample space, and this is the number of outcomes in our sample space. So that's good. That's a good question. Differentiate the two, right? The difference between the sample space and just the number of outcomes in your sample space. So if you're being asked for to show what the sample space is, they're going to have to actually write out all of the possible outcomes. They want to know the number of them. And so we already really did talk about this. So we have events that count that. Yeah. So we already talked about each of these, right? A simple event has one outcome. If there's more than one outcome, it is not a simple event. Not too bad. I don't think that we really need to focus too strongly on that. Okay, here we go. If we ask a student's age at his or her last birthday, let's determine the number of outcomes of each of these events, and then decide whether each event is simple or not. Let's explain our reasoning. Event C: the student's age is between 18 and 13. So what are our first possible outcomes? Our sample space looks like 18, 19, 20, 21, 22, 23. Well, that's really weird. I meant to say 23. I'm not sure where 13 came from. I was already thinking ahead. I wanted to say that this is not simple, right? The student's age is 20. The only possible outcome is 20, so this is simple. So this says an event can occur in m ways. So this is a variable, okay? This is also a variable here. This here says m times n, okay? M times n. And this is quite handy. It makes it so that you don't have to necessarily draw out that whole sample space using those tree diagrams. You can actually kind of figure it out and then multiply. That's what that's saying. And we'll get a good example of that here in a second. So let's go ahead and use this rule. Okay, so if you're purchasing a new car and you have possible manufacturers, car sizes, and colors listed, these are all the ones you want. So you have Ford, GM, Honda, Toyota, compact, midsize, right? Those are four manufacturers. You have 2 possible sizes, and then you got 1, 2, 3, 4, 5 possible colors. How many different cars do you have to choose from? That's the idea. How many different cars do you have to choose from? So here we have 4 different selections, right? Here we have 2. And here we have 5. So we're going to use that rule, right? It should be the case that there are 4 times 2 times 5, or 40 different cars for us to choose from. Let's see, should we go ahead and make a tree diagram to prove that that's true, or not? Okay, here we go. So, let's look at this situation. We've got license plates. So, I've got 6 blanks that can be on my license plate. Alright, I like to draw pictures of stuff so that I can see it better, right? This one can be any number from my 26 alphabetical letters. So how many possibilities are there for this, just this one slot? There are 26. And then this one also, right? 26. This one has 26 possibilities. And so on, right? So, imagine if we were to draw like a tree diagram for each of these, right? There would be an A, B, C, D, E, F, G, right? For each of these. So then what would be our total possible outcomes? How many different license plates can you make?
A lot.
Close. You guys are close, right? It's actually going to be, remember, it's going to be, you're going to multiply each of these, right? So 26 to the 6th hour, right? So 26 times 26 times 26 times 26 times 26 times 26, right? So you're talking for this one, 26 to the 6th power. That is a lot. How about the next one? So I really feel like drawing a picture helps me out a lot. And so you may also want to do this. I'm going to highly encourage you, strongly encourage you, I should say, to draw a picture of these things. They'll make a lot more sense. Okay, so 6 out of 26 alphabetical letters, each of which cannot be repeated. So this license plate is going to be 6 out of the 26 letters in the alphabet that I can't repeat any, right? So this one, I have 26 options. But now I've chosen one, and I can't repeat it. So then this one has now one less option, right? Because one of the letters is used over here. This one, now I have 2 of the letters. So each time I go down, right, I have one less letter to choose from. So then how many are going to be in this one? It's going to be 26 times 25 times 24 times 23 times 22 times 21. I don't have that calculator, but I think it's calculated here. Turns out to be 165,765,000. A lot of different license plates. Huh? That'd be nice. I would definitely give some money away to people. It'd be fun. You wouldn't? Studies show that people that give money to other people are happier than people that don't.
The studies show that if I had that much money, I could buy a lot with that.
Yeah.
And I'd also be happy.
Yeah.
You can do. I was thinking more outside. You need money to make money. You need a lot of money with that money.
That's true. Okay, so number 3. Let's look at number 3. So we'll go. And the answer is global. Let's do a diagram. So 6 out of the 26 alphabetical letters, each of which can be repeated, but the first letter cannot be A, B, C, or D. So that means that I have 4 less, right, to choose from. But each one of these have 26 possible letters, right? So then it makes sense that we would do 22 times 26 to the 5th.
Wait, the other ones can have 26?
Yeah, it says the 6 letters in your license plate, right, can be the 26 alphabetical letters, except for just the first one. The first one can't be A, B, C, or D. Yeah. That's kind of a confusing. It's worded a little bit confusing.
So just the first license plate?
Just the first number, or the first digit. The only constraint is on the first digit. The other ones can be any of the 26 ones.
So because there's other 26 letters.
No, it's just the first letter can't be A, B, C, or D. The rest of them can be any of the 26.
Oh, okay. So this whole thing is like.
It's a license plate,
Oh, I
yeah.
was thinking somebody should figure it
Oh yeah, so this is each one of these boxes represent one of your
out.
letters on your license. Yeah.
Okay, uno, mingo, down.
Okay. And we will come back and talk about this